Today we're looking at congruent triangles and specifically how they, corresponding parts of congruent triangles. When you know, looking at the term right here, when you know two triangles are congruent, you can make a conclusion about the sides and the angles of the triangles. For example, we have two triangles that are given to us saying that they are congruent. We're going to write 6 congruent statements about corresponding parts. Congruent statements is, for instance, example, angle A is congruent to angle B. Those are congruent statements. So the first thing we're going to talk about are identifying corresponding sides. The corresponding sides, we can't just randomly list two triangles as being congruent. The order that the letters are in tell us a lot about it, so we have to make sure that they are corresponding. For instance, if I have RG and I say segment RG, it's going to be congruent to segment MQ. The order is important. If I have these in the wrong order, we will be saying that two segments are really not congruent, so they have to be corresponding. What does that mean by corresponding? If I have two triangles that look like this, and this is RGK, well, then the other triangle has to be MQB, because we're saying that RG, this segment, is congruent to MQ. You see that if I wrote these in the incorrect order, I would be saying two segments would be congruent that aren't. So that one is congruent. Now, we then would look at the last two letters. GK should be congruent to QB. GK is right here, QB is right here, which would be this blank right here. And then we have one more congruent statement which we could make, and that would be RK, the first and last letters. We would say that segment RK is congruent to segment MB. Again, the important thing is making sure that when we name congruent triangles, that the corresponding parts are congruent. So those are 3 congruent statements that we can make based on the sides. Now again, we can also do that with the angles. And with corresponding angles are named using letters in the same position on either side of the congruent statements. For instance, R is the first letter is congruent to the angle in the first letter, M. Likewise, G is congruent to Q, the second letter, so we would have angle Q there. And the third one would be angle K is congruent to angle B. And there are 6 more congruent statements. Okay, so let's look at this. We're going to look at this triangle. One thing that we use in proofs is this phrase right here. Corresponding parts of congruent triangles are congruent. It's a lot of writing, so we will see that abbreviated by CPCTC. Corresponding parts of congruent triangles are congruent. So when you see that abbreviation, that's what that means. Okay, so here we have 2 more triangles. If you know that triangle ABC is congruent to DEF, what 6 congruent statements about segments and angles can you write? Well, let's look at this not even looking at the picture. We should be able to do it just by given this information. Let's do the angles first. We would say that angle A is congruent to angle D. The reason is they're corresponding parts. It's the first letter in the triangle. Angle B would be congruent to angle E. Angle C would be congruent to angle F. So those are my 3 angle congruent statements. Now let's make the 3 segment sides congruent statements. We would say AB are the first 2 letters. So AB is going to be congruent to the first 2 letters of my next triangle, which is DE. The second 2 would be BC, and that would be congruent to the second 2 letters, which would be EF. And then we take the first and the last letter, AC, and make that congruent to the first and the last letter, which would be DF. And there we have the congruent, 6 congruent statements. 3 angles, 3 segments. Now let's look at how this looks in comparison to these triangles. Okay, so what we're going to say here is angle A is congruent to angle D. That means this angle is congruent to this angle. Angle B is congruent to angle E. So this angle is congruent to angle E, which is this angle. C is congruent to F. And then we have segments. AB is congruent to DE, so there's AB, there's DE. And then BC and EF. And then AC and DF. Okay, so we've labeled all the congruent segments, all the congruent angles, and now we can find all the angles in this triangle, because we can say congruent corresponding parts of congruent triangles are congruent. For instance, here angle D is 73 degrees. Well, D is congruent to A, so A would also be 73 degrees. Angle B is congruent to angle E, so angle B would be 65 degrees. And then angle C would be the same as angle F, since they're congruent, which is 42 degrees. And then we can see that segment DF is 3.5 degrees. Well, it's congruent to AC, so AC is 3.5 degrees. BC is congruent to FE. BC is 3.7, so FE is 3.7. And then the last one would be 2.6. These two segments are congruent. So that's how we're able to use this corresponding parts of congruent triangles are congruent. Okay, so here we have 2 triangles that are congruent. The question says, is it possible to determine if the measure of GBH, or what the measure of GBH is? If so, how and why not? So what we are given is a statement that says these 3 triangles are congruent. So based on that statement, we can look at this triangle and see, for instance, angle A is congruent to angle B, which is also congruent to angle H. So this angle is congruent to, now B, what is B? It could be 3 different angles, but remember, we're looking at triangle BCH, which is this triangle right here, which would mean this angle would be congruent. So I'm going to erase this just to clear it up for us, but we do know which angle we're talking about when we say B. Okay, and then angle H, which would be this 3rd triangle. Now, we also know that angle B is congruent to angle C and angle let's see, where's angle B? Angle B in the 1st triangle would be here. BCH, angle C would be here. And G in the 3rd triangle. Okay? And I think I labeled this incorrectly right here. B would have been this triangle, and then it would have been H here. Sorry about that. Okay, and the last one would say that angle G is congruent to angle H, which G would be here. H would be here, because we're talking about this 2nd triangle, and then the 3rd triangle is this one right there. So, then we would find corresponding angles or segments. For instance, AB is congruent to BC and HG. AB is congruent to BC and HG. And then we also have BG congruent to CH and BG congruent to CH and GB. Now GB is the same as this one, so we don't have to mark it twice. And then we have the other ones congruent, which would be AG and BH. And BH is also HB. So there you have it. So let's look at what the questions say. Is it possible to determine the measure of GBH? Well, if you'll notice, everywhere we have the measure of angle A, which is 59 degrees. Well, angle B is also 59 degrees, which also this angle is 59 degrees. Now, the other one, the one we did in blue, we have 27 degrees here, this angle, which means this is 27 degrees, and this is 27 degrees. So what is the measure of GBH? Well, we're looking at GBH, this angle right here. Well, if I look at this triangle, I have two angles, which means I'm going to add 27 plus 59, which I get 86 from, and I'm going to subtract 86 from 180, because the sum is going to be 180. And I get 94 degrees. That means that GBH is 94 degrees. This angle is 94 degrees, and this. So now I know all the angles. Is it possible? Yes. The measure of angle GBH is 94 degrees. And how do we know that? Well, because corresponding parts of congruent triangles are congruent. Because I had congruent triangles, those angles were congruent because they were corresponding angles. And the next question says, the student claims that B is the midpoint. I'm talking about this segment right here. B is the midpoint of AC. That whole segment right there. Is that true? Well, it is true. It looks like it's in the middle, but how do we know for sure it's in the middle? Well, look at this. These two segments were corresponding sides of triangles. They're congruent, therefore B is the midpoint. That's the definition of midpoint. So the answer is, do we agree? Yes, we do. AB is congruent to BC. All right, and the third angles theorem, we're going to talk about it just briefly. All of this really says is, if we have two triangles, with two pairs of congruent angles, then the third pair is congruent. That means in this figure, if I've got ABC, and I'm saying that angle C is congruent to angle K, and angle B is congruent to angle J, well, that's two pairs of congruent angles. That means this third pair has to be congruent. Doesn't mean the triangles are congruent. It does mean that the angles are going to be congruent, though. Okay, let's look at the assignment. Okay, right here, all you're going to do is use corresponding parts of congruent triangles to find the different lengths. For instance, in this one, we have these two pairs of congruent triangles. Find AB. Well, AB is this segment. It's congruent, it's the first two letters, to DE, which is this segment. Notice that DE is 3.5 millimeters. Therefore, segment AB is congruent to that, so it must have a length of 3.5 millimeters as well. Now look at angle E. Angle E is this angle right here. Its corresponding angle is angle B, which is this one right here. They're congruent. Well, look at angle B. It's a right angle. That means angle E is a right angle, which means that the measure of angle E is 90 degrees. Okay? And you'll do 2, 3, and 4 like that. 5 is exactly like the first one. We're going to name 6 congruent statements Remember, 3 are going to be angles, 3 are going to be segments. And we can do that without any pictures. Number 8 is kind of tricky, and I'll explain why. We have to find the measure of angle L. That's this angle right here. Well, it's x plus 15, and if we look at the corresponding angle to angle L, it's going to be angle D, which is right here, and I don't have a value. Normally I have a value, I set them equal to each other and solve for my variable. So I need to figure out what this value for x is so I could plug it into this expression. Well, if I look at my triangle, I notice that this has an x, ED is 2x plus 3. Its corresponding segment is this one, LM. They're congruent, it's 53, or its length is 53, it's not degrees, it's not an angle. So we're going to solve for x by saying 2x plus 3 equals 53, and then solve for x. Subtract 3, divide by 2, and x equals 25. Now that I know that x equals 25, I plug it into this expression, and 25 plus 15 equals 40. Therefore, the measure of angle L is 40 degrees. Number 9 is very similar to that. Okay, number 10. They don't give you a picture, but notice that they give you DE and IJ. Notice that DE is the last two segments, or the last two letters in the triangle, and IJ are also the last two letters. That means these two segments are congruent to each other. So we would say 9x equals 7x plus 3. Solve for x, and we get, sorry, that should be an equal sign right there. We should get x equals 3 over 2. Plug 3 over 2 back into DE and solve for the length of DE. 11's the same. The rest of it I will let you handle on your own.